All right. Welcome to today's Corundum developer meeting. I guess this will be the first one on the new Wednesday schedule. So I'll go ahead and get right into it. So first we got announcements and then status updates. All right. So for announcements, the next developer meeting will be on March 6th at 9 a.m. and 9 p.m. The next Switch meeting, I think what we're going to do for the Switch meetings is discuss this briefly last time, is do it the second and fourth Wednesdays. So that'll put the next one on February 14th at 9 a.m. And we're just doing one session of those. So if the 9 a.m. doesn't work for you, well, I guess that's too bad for the Switch meetings anyway. So yeah, I have the meeting information for the current developer meetings and the Switch meetings listed out here. So the subsequent current developer meetings are all going to be the first Wednesday of each month. We're going to do 2 sessions each day. So this is the first one today. We'll see if anybody shows up to the one this evening. hopefully that's useful for a few people. And I went ahead and listed all the developer meeting dates here. I also have a calendar with all of these plugged in. I have a link to that both on the Zulip, and I also sent that to the email list. So you should be able to add that to your Google Calendar. I'm not sure if there's any other formats that might make sense to provide that in. If anyone has any questions or comments, feel free to ask. Yeah, so that's about it in terms of announcements. So I'll move on to the status updates. All right, so there's a couple things that I've been chipping away at here. With the work that we're doing at UCSD in terms of getting our, research set up operational, I've had to do a bit more chipping away at some of the Mac and Phi components because the FPGAs that we're using are a little bit small. So got to get out a bit of a, shoehorn to try and squeeze everything in there and get it to close timing. So I've made a couple of additional adjustments to the Mac and Phi and also the PTP timing components to try to improve timing performance and such. Still working on the new internal scheduler. I mentioned last time that we added the TDMA bit error measurement module and the corresponding user space tool. Well, basically the updated version of the module plus the user space tool that works with the new module. So that's going to be going into the repository soon. Also, the application that I've been putting together for the research project that facilitates the forwarding necessary for the circuit switching research that we're doing, I'm going to put that in the repository as well, basically as an example application to show you how you can do, some basic packet processing and forwarding and whatnot. Had a few people asking about, example applications for that sort of thing. And well, we can consider the circuit switching application to be an example of that. And then also some updates on the application section pass-through and the testbed status. All right, so moving on, Mac and Phi optimizations. So the main thing that I've been chipping away at here are basically trying to find the long timing paths in the Mac and the Phi components and the PTP TD leaf clock, because all that stuff has to run at around 400 megahertz at 25G, which means, you got to be careful about, number of levels of logic and whatnot. So I've done some work to rework some of the internal logic in the Mac for the error and termination character handling, shift some stuff around, reduce some internal state bits, basically, to try and simplify some of the logic. I also added a couple of additional tests for underrun and T-user assert, just to make sure that the Mac was doing the correct thing in those cases. And I found a bug in the Gigabit Mac related to underruns. That's been fixed now. And I also did a pretty significant reworking of how some of that, of how these states are handled. Just basically the idea is to try and bring it as close as possible to the, normal frame transmission out of the Mac. And this does a couple of things. One, it simplifies the internal logic. And two, it means that if you do have an error, that the frame the error frame actually gets effectively padded out to the minimum frame length. So we're not generating runt frames. Even though it is marked as an error frame, it still keeps the timing correct there. And then the other thing I did is I reorganized the increment computation in the leaf clock for PTP, and this should it's basically avoiding several chained adders in the same clock cycle. Adds a few registers, but I think it helps with the timing performance. As a quick aside, I've been slowly, I think, getting a better handle on how to properly optimize HDL code. And one thing that, kind of coming from an embedded systems background and trying to write code that fits on a really small microcontroller, one of the things that you try to do is, reuse variables or use as few variables as possible so you're not eating up a lot of stack space or a lot of globals or whatever. But using that same technique in HDL is not necessarily the best idea, because while you'll save a few flip-flops, you might end up using more LUTs. And if you know about how the FPGAs are internally built, inside of each slice, you have a LUT and you have a flip-flop right there next to each other. So if you don't use the flip-flop, it can actually be difficult for the tools to use that flip-flop for something else. So by trying to save flip-flops, you might end up using more LUTs, and then those LUTs can potentially prevent the tool from using some of the associated flip-flops later on. So the end result might be even worse than just using a few additional flip-flops. So that's one thing I've been trying to do, is go through, and if there's some clear places where, okay, yeah, I should probably put some flip-flops here, that's what I've been trying to do, because I think it's not going to make a big difference to maybe the slice utilization, but if it's improving the timing performance and potentially helping with, routing congestion and whatnot, then I think you're going to get a bigger win versus just, oh, hey, we saved a few flip-flops, which I don't think is necessarily all that helpful by itself. So I think these changes have all made their way into the the Ethernet repositories and whatnot, and I think I got that pulled back into my development repository. So hopefully that'll be available in the mainline upstream repository soon. So moving on to the internal scheduler and flow control stuff. So this has been on hold for a little bit because I've been working on, we had a paper deadline last week, so I had to get stuff working for that. But I'm going to transition back to working on this relatively soon here. Again, the idea behind this is to support multiple ports and multiple priorities inside of one scheduler block. And then also have the scheduler block maintain its own internal flow control state to avoid head-align blocking in the main Corundum data path. So that's done on this. I'm chipping away at getting the new scheduler working, and I have at this point, I think, a pretty good plan for how things need to fit together. I think what I am going to do is do it in a couple of stages. So the first stage is going to be maybe not the most efficient from a logic resources and block RAM consumption standpoint, but it's at least going to be functional. And then the next stage would be, we're not going to change the external interface or anything, but we're going to try and reduce the footprint. So the new scheduler that I'm working on here, it uses multiple levels of scheduling, where we do round robin across the ports, priority across the traffic classes on each port, and then round robin on the scheduled queues inside of each traffic class. And the queues can be scheduled on multiple ports, but only on one traffic class per port. So it's not quite the same as having, if you have like 8 ports and 8 traffic classes, it's not the same as having 64 schedulers. You basically have 8 schedulers, so it's a little bit more efficient in terms of the resource consumption and whatnot. The initial version, I might not do that. It might be, a bunch of individual ones, but that'll be, one point that I'm going to try to improve going forward. And then we need the internal flow control to manage the buffer space in the transmit data path. So we're going to need to be able to adjust how much buffer each traffic class is allowed to use at any given point in time. And then operations can only start if there is at least, space to send, one MTU size frame. We'll have one scheduler channel per TC per port, and the flow control will be configured and tracked on a per channel basis. The internal flow control, talked about this a little bit before, but the idea is we need to enforce a byte limit and possibly a packet limit on a per TC basis. We don't know the size of the packet until it's being sent, so we have to assume the worst case. And if we're always assuming the worst case and we don't do anything else, then this is going to be somewhat inefficient in terms of the buffer utilization. So we might want to have some way of kind of reclaiming some buffer space if we're sending a lot of small frames. So the high level idea is that it kind of works like a credit card effectively, where you can reserve space in the buffer for the full size or for the full MTU size frame. And then when you actually initiate the operation to send the frame and you know how big the frame is, then you can release the unused portion and then that can be recycled. And then at the end, you recycle the full amount. So I have a scheme for how to do this. Talked about this before briefly. I'm not going to go over it again at the moment. But I think I went through a few different ideas to try to come up with something that's going to be simple and should be implementable on the FPGA. But yeah, so hopefully in the next week or two, I'll chip away at this and see if I can get this operational as part of the new scheduler. Yeah, so I think we have all of the hooks in place for actually implementing the flow control in terms of feedback from the various points in the data path. Just the flow control scheme needs to be implemented inside the scheduler. So moving on from the scheduler, I've got the TDMA BER module that I've gone ahead and added to the repository here. Well, I guess the old version has been in there for a while, but since we've been trying to get this thing to fit on a relatively small FPGA, I had to sit down and kind of rework things a little bit, and I did more or less a complete rewrite to significantly reduce the footprint while maintaining all the same capabilities. And the idea with this module is it can do it's intended for low-level link-level characterization of layer 1 switches. I guess you could use it for electrical switches, but it's probably more useful for optical switches. And basically what you can do is synchronize the switch with PTP time, and then all of the NICs can basically derive a schedule from PTP time and use that to control the binning of the collected bit errors. So currently it's set up to run the PHYs in PRBS31 mode, but I've actually come up with a couple of other potential ideas for actually not looking at the bit error directly, but looking at some, I suppose, alternatives to the bit error information that might enable you to use this without actually placing the PHYs in PRBS31 mode. Because if they're in PRBS31 mode, you can't send actual data. But if you look at things like the block error bit out of the PHY, then you might be able to do something similar, but shall we say online, because it'll work with the link working normally, but you can still collect some information about the link quality. So I may be looking at making a few modifications to this module to support some of these additional use cases. So yeah, this base setup consists of basically two things. One, we have the TDMA BER measurement module, which is the HDL that goes in the design, and then we have a user space tool to control it. So the user space tool will look for the register block for the measurement module, and then it can control the operation and collect the data. So the old module has been in the repo for a long time and used kind of a screwy setup for interfacing. So that the new module has been cleaned up and optimized. It uses a new register block setup, so it's much easier to detect that it's present and where it is. And then the user space tool that is set up to use the register block thing, that's also going into the repo as well. So I think for right now, I've ported 2 designs over to using this new module. I need to go through and do the rest. But before I do that, I might make a few additional changes to the interface, because I don't want to have to go through and re-edit all the designs to just add a couple of pins or something. So hopefully I'll get that polished off within the next couple of weeks here. Then just a brief overview of the little tool. So the bit error test tool basically what you can do is you can specify the schedule start time, schedule period, time slot active period, to define, where you actually want to take the, or where you actually want to collect the bit errors. And then you can measure the BER in one shot across either the entire active period, or you can split each time slot into a bunch of much narrower slices. And then you can measure up to 32 slices per time slot concurrently. 32 actually might be able to do more than 32. It's dependent on the size of the internal RAM and the number of time slots that you're using. But I think you can do more than 32, depending on how many time slots you have in the schedule. And then the time resolved BER data, it dumps it out as a CSV file, but you can plot that as a heat map or as a time series if you want. And you can use this for, characterization of layer 1 switches to figure out, how long does it take the transceiver to lock, how accurate is your time synchronization, things of that nature. And then also for the experimental optical switches that we're using, you could potentially have, little defects and things in the middle of a time slot. So this can allow you to characterize how many of those there are and where they are, things like that. And then potentially there's either you can improve the design of the switch to avoid those, or, there might be other ways of working around some of these things, pause traffic during one of the defects or whatever. So that's going into the repository. Well, that's in the development repository at this point. So that'll end up in the mainline one relatively soon. All right. So moving on to the circuit switching application. So this is something that we've been working on for the circuit switching research at UCSD. And this basically drops into the application section in Corundum. And the idea is that with this application, you can do a bunch of different things. One of them is you can do time-based scheduling. So you can pull from queues when the circuit switch is in a particular configuration. You can also do the time-resolved BER measurement stuff. It also has a module for what I'm calling TDMA guard enforcement. Basically, it can pause the transmit traffic based on PTP time, so you can avoid sending traffic during switch reconfigurations and things like that. And as part of that, if you have the enforcement to prevent traffic from being sent, then you can actually kind of you can walk the transmit schedule back a little bit and try to get stuff spooled up in the transmit queues before the start of the time slot. You can do some fun stuff like that. It also, the other thing is that for the networks that we're putting together, we've developed a couple of different indirection protocols for forwarding traffic through the optical switch. And there's basically two different protocols that we put together. One of them is the Opera indirection protocol. The other one is something that we call rotor LB. So Opera indirection protocol, it's basically a low latency cut through indirection. And then we use time-based routing where we have several different routing tables, and depending on the position of the switch, we'll use, one table or another. And the idea with that is you can send traffic with a relatively low latency through the optical switch, because you don't need to wait for the next time slot. You can send something now, and maybe it'll have to bounce through a couple of hosts to get to its destination. And then the rotor LB is a store and forward setup where data will be stored at an intermediate host and then sent during a subsequent time slot. So optimally, what you would do there is store the data on the FPGA board in DRAM of some kind, and then forward that. So with the FPGAs that we're using right now at UCSD, they're not big enough to add all of the rotor LB functionality, and they also don't have enough memory bandwidth to support that. So potentially we can support that in the future if we were to get different FPGA boards with HBM or something. But for now, the circuit switching application supports the Opera indirection protocol. And also we were doing some thinking on how to basically emulate the switching of a circuit switch without actually having it, by using basically time-based encapsulation. So that code is not written yet, but potentially that will be added at some point as well. So this, while some people who are doing circuit switching research might find this useful from that point of view, this application does have to do basically some straightforward packet processing and routing inside of the application section. I've had a few people ask about, hey, do you have an example application for this? Well, we can use this as an example of how to do that. The other thing is putting this together has gotten me thinking about how to, or kind of what needs to sit between the core data path and the ports. And what we have right now is maybe not really the best setup, but if we're going down the route of the packet switch that Carlos has been working on, once we get that to a point where we can integrate that into the data path, then there might be some additional kind of opportunities for optimizing things a little bit and taking advantage of some of that switching capability with these kinds of forwarding applications that might end up being a little bit more efficient than the more or less fully parallel data path thing that I have set up at the moment. So this application logic could be undergoing a pretty significant overhaul at some point, but you got to start somewhere, and hopefully I'll be able to get this into the repository relatively soon. Not just the application, but also a couple of little control utilities for poking at the internal registers and setting everything up. And also, just here's a real quick block diagram of what's going on for this application. We drew this up a while ago, so it's not 100% accurate as of in terms of how things are built, but it's kind of at a high level, more or less what's going on. So the gray stuff are things that are not currently implemented, but just at a high level, the idea is that the application software will send a packet. It'll go into the standard Corundum transmit queues. Then we have the Corundum TX data path, which will use schedulers that are connected to PTP time to determine who gets to go and when. The TX data path will fetch the data and hand it off to either the Opera transmit or the Rotor LB transmit. These will, for Opera, this does the time-based routing to determine, which port to send it out of. For the Rotor LB, that would basically just do encapsulation. And then we have the transmit FIFOs that hand the data off to the output ports where it actually goes to the optical switch. And then on the return path, when the data comes in from through the ports, it goes through the RX FIFOs, and then it either goes to the Opera receive or to the Rotor LB receive, depending on which type of packet it is. For Opera, it's either local traffic that gets sent directly to the host, or it's traffic that needs to be sent somewhere else, in which case it'll go through the time-based routing and it'll get sent to the appropriate transmit FIFO. It'll go back out on the wire. For Rotor LB, again, it's either local that gets sent to the host, or it's remote traffic that needs to get indirected, in which case it'll get stored in HBM, and then in a subsequent time slot, it'll get read out and sent to the to one of the transmit ports. So again, the stuff in gray is not going to be implemented for a while, but the stuff in blue here, in terms of the implementing the Opera protocol and doing some of this forwarding, that's implemented in the in this scheduling, in this circuit switching application, which hopefully we're going to get into the repository pretty soon here. All right, so I think that rounds up that. Moving on to the application section pass through. MLE opened up a pull request a while ago for this. What I think I'm going to do is probably later this week take that pull request and see if I can sort of finish it off in terms of getting all the simulation stuff working and getting that code integrated into Corundum and finalized in my development repository. I think at least having the ability to pass in some parameters to the application section could be useful for say the circuit switching application. If you want to change some of the settings, that could be a pretty useful capability. And it would just be nice to get that polished off and in the repository, so it's all usable for everybody. So I'm going to work on that. Hopefully this week I'll be able to get that polished off, unless we hear from the MLE folks and they want to update the pull request. So I guess we talked about this for a couple of meetings and haven't heard much. So I guess they're probably pretty busy over there. So I'll take a look at that and see if I can get that squared away. So I think it's pretty much ready. It's just there was a couple of test benches that are missing. So shouldn't be a big deal, I don't think. All right. And then last thing I want to talk about here is the Corundum test bed that I've been putting together. I guess I didn't put a picture of the test bed setup. It's a little bit of a mess, but I posted a picture in the Zulip channel. At this point, it's more or less operational. I just got I set up a VPN last night so that you can connect to it, and I set it up in kind of a bridged mode, which is kind of cool because when you connect to the VPN, then you can basically just directly see all of the equipment in the test bed, as opposed to having to, jump host through the controller or something. I also got both of the Arista switches that I have connected as well. I have an Arista 7060 CX 32 port 100 gig switch, and also the 7132LB that Arista sent me. That's the FPGA based switch. So those are both plugged into the management network, and I plugged in a couple ports into the optical switch. I'm realizing though that a 32 by 32 switch is not actually big enough, although most of the ports are currently taken up by the high-tech global FPGA boards. So maybe I need to revisit a little bit how things are connected. We'll see. But yeah, I think the idea, well, I guess the other thing with the test bed is I don't yet have I only have one host machine, and it's not yet set up for diskless net booting. So at least for the time being, we'll just have to, manage that as a normal PC. But hopefully in the future, I'll have that set up with diskless booting, and then everybody can have their own image. But yeah, so I'm not going to open this thing up just to the public generally. If you want to use it, talk to me and I can get you set up. So yeah, if anyone has something they want to try out on here, or if you're running into some weird problem and, need some help debugging, this would be a good method for doing that sort of thing. And also for doing the switch testing stuff. It could be a nice setup because we've got two of those high-tech global FPGA boards and the network tester. Oh, I did test with the ONT Scout software, and it does work through the VPN setup. It doesn't work properly with the previous thing I was using, the SSH shuttle thing. It's a very nice piece of software, but I think it only works with TCP. If there's like UDP traffic, it doesn't work. But with the VPN setup I have right now, it seems to work fine. So that's good. Makes things easier to deal with. You don't need a VNC into the thing. You can just run the little Java thing locally. Yeah, so that's about all I got to say in terms of the test bed at this point. So if anyone's interested in using that, let me know, and I can look at getting you set up with access to that. I think that's about all I got in terms of updates for today. Yeah, so if anyone has any questions or comments or things you want to discuss, go ahead and fire away.
Hello, Alex.
Hey.
Well, I have one question regarding your latest optimizations on the Mac and Phi components for the wrappers. Should I, for the switch development, should I update some of those files or are more related with the 10G, 25G?
But this is only for the 10 gig and 25 gig stuff.
Yeah,
it doesn't affect the CMAC, right? Because the CMAC is the Xilinx hard logic.
Yeah,
so
right.
Yeah.
Okay, but there is no modifications on the wrappers for the 100G?
Yeah, I didn't make any changes to the wrappers. This is just in terms of the Mac and Phi core logic itself.
Okay.
Since the wrappers, there's not all that much in there, right? It's you got the transceivers, and the wrappers are mostly sort of management logic for the transceivers and clocking and whatnot. So there's not much there that really needs a high level of optimization, because I think even though the DRP stuff runs maybe 125 megahertz or something, it's quite slow. So
yeah, I think so.
Yeah.
Okay.
But yeah, eventually I might make a new set of wrappers that lets you, not necessarily negotiate, but at least reconfigure to whatever speed you want. So something like that, potentially it might make sense, because then you could run the switch with some 25 gig ports or whatever, or 10 gig, or at some point maybe even 1 gig. But yeah, so that's
more.
That's a bit down the road though. Yeah.
Okay, cool. Thank you.
Was somebody saying something? I heard something there for a moment.
Hello, it's Julian.
Oh, hey, how you doing?
Yeah, I'm fine. I'm sorry I didn't came to the previous meetings. This
That's fine. It's fine.
the last one. But I had some health issue, and so I couldn't be there
No
as
worries.
much as I want. So yeah.
Your health is more important than these meetings, you know.
Yeah, I know, but anyway, I wanted to know if you have a list of you say on the test bed there is a various FPGA and board and all of that. Do you have a list of them somewhere?
I mean, so right now I just have a couple of FPGAs in there, but basically I can take any FPGA that I have and whack it in there if we need to test on something. So what's the list? Go to the Corundum repository, look at the supported devices list, and take your pick.
Okay.
Basically.
Okay,
I mean,
nice.
I guess the only thing that would be tricky is like the VCU 118 or VCU 108, which are just big. You can't really put those in a computer. So pretty much anything else on that list, I can figure out a way to get it into the test bed. So
okay, so you have one. You have one. No, because I know that I own some kind of U50 from Xilinx, and also on a personal matter on some smaller device, also Xilinx. But recently, I got access to some Polar Fire.
Okay.
You know, and I'm not sure I will be able to take one from the job, from my job, but if I can, that would be interesting to test. I don't know. I didn't see them on the supported list.
Right. I think right now it's basically just Xilinx and Intel devices.
Yeah.
So,
okay. So that would be interesting to know. I was just curious. I mean.
Right. Yeah. I mean, it might be interesting to look into what it would take to run Corundum on some of these other devices. It's going to be, I think, mainly dependent on what the interface logic looks like, right?
Yeah,
so the Ethernet, I think, is more straightforward. Well, maybe. But the PCI Express side is probably the real sticking point that definitely requires the most work to get Corundum running on a new device. So I've looked at a couple of these. I'm not going to say third-party FPGAs, but not Intel, not Xilinx devices, and some of them have really screwy PCI Express interfaces. So some of them Corundum won't run on. Some of them it might be possible, but it might require a lot of work. So I don't know about the specific board that you guys have, whether that one is workable or not. It would require a pretty deep perusal of the PCI Express documentation, I think.
Sure. In fact, I'm in a team right now that we are designing our own board based on reference design from that Polar Fire FPGA. Polar Fire is a micro semiconductor, It's a quite well-known.
I've heard of them.
Yeah. So it's quite, common in non-FPGA domain, but I didn't even know that they were doing FPGA, in fact.
Oh, okay.
So I just discovered it at the time, and we are going to use the 10 gig interface on this project, and also the PCIe.
Oh, okay.
So yeah, I might have some information on this later on. That's why I was curious about.
Yeah, I mean, it's great seeing more devices support at least up to 10 gig speeds. So yeah, if it doesn't support 10 gig, then it's like, whatever. It's probably not worth the time and effort. But if it does support 10 gig, then it's like,
it does, and it even supports more. I think it supports 25, I think, something like this.
Oh,
so,
okay.
Yeah,
I know they have some that support 10 gig. I didn't realize they had some that support 25 gig. But they're releasing new stuff all the time, and I don't really follow those devices all that closely. So that would be.
And one interesting bit of that is that it's for the special device. It's a special certified device, so it can get in the air, and the FPGA itself, it's certified to go in space.
Oh, like some sort of a rad hard type setup? Oh, okay, okay.
So
Yeah, that
it
could
has
be
been
that could be pretty useful.
well, if you do satellites, yes.
Well, yeah, I
But
mean, not for me personally, but I can see that for some people that would be
yeah.
useful, or maybe even people at CERN would find that stuff useful. Not so much for sending it to space, but I mean, various parts of the accelerators they have there, I think,
Sure.
are
So
pretty high
so I know
radiation
that
environment.
for now they are using IPs from the brand, and
Right,
they are sticking to that, but they are always looking for other solutions. And since I basically we are going to use it as a sort of network cards also,
right,
a NIC, with also the FPGA won't do only that, but at least part of it will be using that. And so
right.
that's where it would be interesting to investigate Corundum as that kind of device. So that's why I was wondering if you already heard of this.
Right. Yeah,
But okay.
I'm aware of those, but I don't have any of their hardware. So yeah, it
Okay.
certainly could be interesting to take a look at.
Oh,
So
sure.
if you have some of those, maybe there's
So, okay.
it'd definitely be
Uh,
worth taking a look at the documentation to try and figure out whether this is something that would be, remotely doable.
okay. I think I can provide that and see if I can borrow a development kit or something. The development kit comes in the form of a sort of PCIe card, with
Right.
a small a stand that you can use either on the table or plug in a PC, and with the correct spacing for you to put in a computer. But
Yeah.
also the card has a lot of other stuff in it. So yeah, definitely it is possible.
Yeah, I definitely seen pictures of a few of their dev boards. So yeah, I think that's a pretty common form factor where they just make it a PCIe form factor so you can use it that way, but
Yeah, you not have to if you don't want
but
to.
it's not necessarily set up like the Alveo board, so they don't do anything unless they're plugged in like that.
Yeah,
I think
exactly.
I think I got like a VCU 1525 at some point, and I'm like, well, let's try powering this on. Plugged into a power supply, nothing happened. It's like, oh, okay. I guess you actually have to install it in a computer. It needs some of the 3.3 volts or 5 volts or whatever to turn on. But some of the other
Oh,
dev
okay.
boards will run just fine on just the external supply. So
Yeah, this is one of these boards. It works like this, where like we are using it for now on the table, like just with a power supply, and that's it for now.
right, yeah.
So,
Yeah, I've got several different Intel dev boards that all work like that.
okay.
Like the Stratix 10MX dev kit, it's like that. You can just run it straight off the external 12-volt power supply. I think some of these, while you can plug it into the PCIe slot, it won't draw its power from there. So you always have to have the external
Sure.
thing plugged in.
Oh,
So
yeah. Okay. Yeah, that's all I wanted to say tonight.
yeah. All right. Well, definitely worth taking a closer look at those things because I think those are potentially a more affordable option than some of the Xilinx and Intel boards. So actually, I think I might even have a Stratix 10 or not Stratix 10, a Cyclone 10 GX board lying around somewhere.
Okay.
And when I get time, the plan is to run Corundum on there, but haven't had time yet. So because those are also a lower cost part. They also support 10G. The annoying thing about the Cyclone 10DX is they have 10G capable SerDes, but they only support PCIe Gen 2.
Yeah,
So it's like
it's bizarre.
the SerDes are fast enough for Gen 3, so oh well.
Okay.
All right. Yeah, well, keep me informed. Those boards sound like they could be pretty cool.
Okay, I will send you a mail with the information and see if I can take one or some dev board somewhere. But
Yeah.
maybe not. It might not be possible right away because we are building a new a new board
Right, yeah.
from scratch for special applications. But when we will move in a few months in the new board, I think the old board, the dev board, won't be useful anymore. and so maybe I will be able to borrow it for a while.
Yeah, it's like once you get the
Mm.
new board operational, then you're just going to
Yeah,
do all the development on your custom board instead of dorking around with the
exactly.
dev board. So yeah,
That's it.
makes
And
sense.
so we have many dev boards that are underused for now, but after yes, I think they will just sleep in a closet somewhere.
They might as well
So
put them to use. Yeah. All right.
yeah, exactly. It would be nice.
Yeah, so I seem to remember. So from the last time I was looking at some of the documentation, just trying to figure out, okay, what do we need for Corundum to work, and what do these boards provide? It's well, so one thing is you need the ability to DMA stuff out of host memory from just anywhere in host memory, and then
Okay.
you also need the ability to basically implement the entire bar space. Implement whichever
Oh,
bars, however, whatever size, that sort of thing. So that
okay.
rules out things like using, say, the Xilinx XDMA core, because the XDMA defines its own bars and whatnot, and you can't really do anything with that. So
Okay.
it's like if you were to use like the XDMA, the driver would have to like do a bunch of extra work that's specific to XDMA and whatnot. So I'm not going to support that sort of thing.
Okay.
Because now you need a board specific driver. It's like, okay, what's the point? So it's a question of, with the PCI Express core on those boards, can you run it like a fully transaction layer core? Some of these boards will let you do that, some of them won't. If they let you do that, then it's probably just a question of how much work is it going to take to, get the design running on there. If it doesn't do transaction layer cores, then it's a question of, okay, it has some internal DMA engine, so is that going to let us do whatever we want, or is there some limitations to that? That sort of thing. So it's definitely got to take a detailed look at the documentation to figure out, is this going to work? And it could
Okay.
be that like maybe some of the microsemi devices will work and some of them won't. So
Yeah.
because they could have very different cores on there depending. So yeah,
Okay.
it'd be interesting to take a look at that, because yeah, if those are low cost devices, then that might make it easier if somebody wants to get their feet wet. Microsemi
Sure.
board might be cheaper than getting their hands on an Alveo or something, but I don't know. I guess the flip side is if those devices are small, it might be more limited in terms of what you can do. Corundum might not even fit on there. We'll see.
Well, I'm not sure they are so small. At least when I look at the die, they look quite big. So, and there is a lot of peripheral on them. So I'm not sure they are so small. And
Right. Well, I mean, it seems like everybody is, releasing larger and larger FPGAs. So I'm not
yeah,
sure exactly which series you guys have, but it's possible it's
I will know that tomorrow. I'm not
okay.
at work right now, but tomorrow I will be able to tell you.
All right. Well, that'd be pretty cool.
Nice.
All right. So does anyone else have any questions or comments, discussion points?
Yeah.
All right.
So I was going through trying to build up and load Corundum on a Ubuntu workstation, and partway through the build, the Ubuntu, I'm on 22.04 LTS, and there was a kernel update from, I think it was like 6.5.0 like 14 to like 15 or something.
Right.
And apparently when that happened, they like bunch of the drivers for other NICs that we had installed in the workstation just stopped working when it was on that kernel. The only way to get it to work was going to the previous kernel. Not sure what happened. It seemed to be after some debugging that the kernel didn't install properly. And so I just had to go back in and manually install the rest of the kernel modules for whatever reason. And so I
That's
guess I
very
was just wondering
strange.
if
That's very strange. I think there's some stuff you can do with APT to have it, check or reinstall particular packages.
yeah, it looked like there was some dependency error, and I guess I was just wondering because I had built the Corundum driver on there. Had there ever been any issues of like the Corundum driver causing any dependency errors, or if you've seen that in the past with other Ubuntu?
So these were dependency errors at the packager level or at the?
I guess I'm not sure. I wasn't ever able to find out. It seemed like the issue was dependencies. I'm not sure what it was though.
Yeah,
It
because
seems like the issues.
so the Corundum kernel module, it's literally just a file that gets insmodded into the kernel after it's loaded. So that shouldn't do anything with the system package management. So I'm not sure what might be going on there.
Yeah, it could be nothing with the Corundum driver. I was just wondering if you'd ever had any issues with that in the past, or if because it could easily be on Ubuntu side or something, or maybe just our build is somehow some dependency was missing somehow randomly.
Yeah, that's very strange. I've never noticed anything like that before, and I think we're running similar versions of Ubuntu as well. So let me just take a look. Let me see. What are we running on the test bed at UCSD? Yeah, so this is 2204 Linux kernel 620-39.
Oh, okay. So yeah, you're on the 6.2. Yeah, we're on the latest 6.5.0-15, it looks like.
Yeah, I think I might need to install another package on here or something. I just realized that I think this is yeah, okay. So the test bed that we have set up right now, we've got basically one control host and then a bunch of nodes that boot off of a netboot image that's running on the control host. So it looks like the control host is running 650-14 and the other ones are running 620-39. So I think I need to install a different kernel package or something to get that updated. They'll have like the hardware evolution or something HWE kernel that you can install to get a newer kernel version.
Yeah, that was part of the thing that
something.
didn't install automatically with the update for whatever reason. That's one of the things I had to install manually.
Oh, interesting.
Yeah, because everything worked on the -14 fine, but the -15 for whatever just didn't build or install properly.
Yeah, that's a little bit perplexing. I mean, it sounds like some sort of packaging issue on that particular machine, probably.
Yeah, it seemed like a machine dependent
right.
issue.
Because especially if it seems like if you had files missing or something, I mean, the Corundum kernel module shouldn't have anything to do with that. So
yeah, okay. Yeah, I was just wondering if you'd had any issues with that in the past.
yeah, not to that extent. I mean, we've definitely crashed computers before, but usually due to me doing something stupid. So
Yeah. Yeah, that was really
creating an infinite loop in an ISR. Yeah, that's a bad idea. Done that before.
Yeah, because it seems like the issues worked out now. I'm after all the kernels were proper or just manually installed, all of the network drivers pop back up. So seems to be fixed now, but no.
Yeah, I mean, I guess there's definitely a difference between like you try to insmod something and it fails due to, you know, some kernel level problem versus it fails because the file is missing, right? If you can't find the file, you know, that's not really a kernel problem, I don't think. So yeah. Anyway, so it sounds like it's working for you now.
Yeah, it's able to
for the moment.
Yeah, for the moment,
Okay.
all the kernels and network drivers are working fine, so everything seems to be okay.
All right, well, hopefully it stays that way.
Yeah. I was like, oh, that's all I just wanted to see if anything had, it was any known issue or something in the previously.
All right.
That was all I had.
Sure. Okay. Well, does anyone else have any questions or comments, or I guess we can adjourn for today then. And again, we got the Zulip, so people have questions, you can go post on there in the meantime until the next session. So, and then we have the Switch developer meetings, right? So I guess we'll have one of those in a week. So if people want to hear what Carlos has been working on, tune in a week. Otherwise, it'll be in 3 or 4 weeks. First Wednesday of March will be the next meeting. All right. Well, if nobody has anything that they want to add, then I guess we'll go ahead and adjourn for today. So
thank
we'll
you.
talk to you guys later.
Thank you very much. Bye-bye.
Thanks. Have a good one.
See you.